All right, so this is the final practice quiz for AP Calc AB that I have. So I'm going to go through them. I've never seen the questions before. So you have 22 minutes to complete the following 10 questions, and we're not allowed to use a calculator, so no decimals, unfortunately. Let's get to it. All right, so three, two, one, go. All right, so here's the graph of function f and the line y is equal to x plus 1 as shown in the figure above. Graphs intersect at the following points. The following gives the area enclosed by the graph. Okay, so graphs. I know that. Okay, so if you want to get the area of something, right? If you want like considering like this is the axis, then if you want to get like this slice, for example, then what you need to do is you need to get this top function right here, and then subtract it from subtract the that's a weird color. Um, subtract from this bottom function, and what you get remaining is this piece right there, right? So you do the top minus the bottom essentially, and you get that piece. Um, so we need to determine which is the top function and which is the bottom function. Um, so yeah, so then go from negative pi over 2 to pi over 2. Okay, this is a weird one, honestly. But you have this f of x is on top. I'm assuming that this curvy thing is f of x, and the bottom one is uh, right here, the one that goes to the y-intercept of 1. That's going to be y equal to x plus 1. So from negative 2 to pi over 2, it's going to be that. Then from pi over 2 to 3 pi over 2, it's just going to be, so I see 1. So from negative 2 to pi over 2, you're doing top is f of x minus the bottom, which is x plus 1. Then you're adding on from pi over 2 to 3 pi over 2, x plus 1, which is on top, and you're subtracting f of x. So 1 is definitely going to work. So that rules out C. Uh, negative pi over 2 to 3 pi over 2. Uh, no, I don't think the 3 is gonna work. Um, just because you're taking the absolute value of that, and nah, it's just nasty. 2. How much time do we have? Uh, I'm gonna go with from negative pi over 2. Okay, this is just assuming that this area and oh yeah, I think that will work. I think 2 will work. Yeah, if I'll explain it if I no, I think I can explain it now. Essentially, basically this area over here is equal to this area over here, and I don't know if I'm able to prove it as to why. But yeah, I'm just gonna move on. This is a weird one. That's okay. You can miss quite a bunch of questions on this. Okay, the region bounded by the curves f of x and g of x are the following. Definite integral is equal to the shaded region. So of course this is going to be top minus bottom again. So this is an x integral, so we're going to get like dx slices. So if you to get this function right here, we're going to get like dx slices. Dx is like infinitely small x width of rectangle. So I'm just going to add them all together. So they're going to go from 0 to 3 of, and again, in order to get this function like this, this galaxy function right here, you just do the top minus the bottom, right? So the top is, I'm assuming it's the f of x because I know when something's like this, it's positive, and when something is like that, it's negative, it's concave down. So I just remember that from like earlier math classes. So f of x has a negative in front of the x squared, so that's going to be f of x minus g of x. You're just going to subtract those. You just want to find the area. Boom. That's going to be, where is it? Just A. Yeah. The pi and all that stuff, that's just making you confused. That's like volumes and all that stuff because you have circle discs instead of just normal, like, rods, I guess. But and all the other ones, I don't know where negative 4 to 1 comes from. Then g minus f, because f minus g will give you this galaxy thing over here. But if you were to do g minus f, you're just going to get a negative integral. Okay, region bounded by these curves revolved around y equals 1. Okay, yeah, you could think about the logic to these types of questions, but honestly, because it takes forever to think about the logic, so I like to just remember, uh, it's okay. Where's the they actually had these intersections right over here, so you don't even have to do any math. So it goes from 0 to 3 again. Uh, I'm just using, I'm just being clever and just using the stuff right over here. So it goes from 0 to 3. Then it's like the outer function, which is f of x, minus the axis squared. I'm gonna make this better. Minus g of x, which is the inner function. So the outer minus inner function, essentially. Or actually, no. Hold up. Y is equal to 1. The outer function would be g of x. Because okay, let me just. Um, I'm gonna take a screenshot of this. I'm just gonna paste it right here. So this is the thing that we're revolving, and if we're revolving around y equals 1, right? So we're revolving. So what we need to do is we're creating these disks right here, right? And then we're rotating it. So in order to figure out that, you just do the outer minus the outer minus the axis subtract from the inner minus the axis. So outer minus axis, right, and then inner minus axis. That will give you this remaining thing. And it doesn't matter if it's negative because when you're taking circles, right, when you're just flipping it around, you're going to square it anyways, right? So that'll become positive, and then you add pi. So then now it's just pi from 0 to 3, and then you have the outer minus the axis, right? So it says, let's go back to here. Right here, they're just doing axis minus. It doesn't matter because you're going to square anyway. So it's 1 minus g of x whole squared minus, so this is the outer, so the g of x is right here, right? So then it's outer minus the axis, and then subtract from the inner minus the axis. So 1 minus, the inner is going to be, in this case, because this axis rotation right here, the inner function is going to be f of x. So it's just going to be that, and that is d. There we go. Yeah, unfortunately, I'm not going to have a lot of time explaining this because I'm going to run out of time. But here. Okay, nice. Something that's a lot easier to explain. Like on the AP exam, area or volumes, those are like my hardest things for me. I would just leave those up to the end. Something like differentiation is a lot more easier though. So if you want to determine slope, nothing but derivative, right? So just yeah, implicit differentiation. So then yeah, you take the derivative of all this. So here it'll be 2x, right? Take the derivative equals, now this is product rule, right? When you have two things multiplied together. So it's u prime v plus v prime u. So u prime is going to be 1 times v. I'm just going to put this all in parentheses, y plus v prime, which is just, it's y, right? So it's just 1. Derivative of y is just 1, but with respect to x, right? Because we're taking the derivative with respect to x. And then dy dx multiplied by u, which is just x, right? So then that's just this middle term covered right there. Then plus derivative of y cubed is 3y squared times dy dx. And then the derivative constants are always 0. And yeah, here over here, the reason why we have that is the dy dx. We're taking the derivative with respect to x. All right. So then now we need to determine dy dx, right? So then I'm just going to expand. I'm going to expand. Just distribute the negative 3y squared dy dx with a 0. I'm going to move all the terms without dy dx to one side. So I'm going to have just 3y squared dy dx minus dy dx x is equal to y minus 2x. I'm just being smart with how I manipulate this. And then dy dx, and I'm just factoring out dy dx so that I can just divide this term minus 2x. So then dy dx is equal to y minus 2x over 3y squared minus x. Okay, so then now in order to find out the slope, right, at the tangent line right there, so you just plug in -1. So it's just we're gonna plug this on -1 and 2, right? So 2 for y, 1 what is it? 2 and then 4 yeah, I'm just gonna plug in -1 for x and 3 y -1. Okay, let's see if we actually get. Oh, we actually do. Perfect. I didn't mess up on any math. That's my weakness on AP Calc. Okay, anyways. We got this 4/13. That's kind of easy. Okay, we need to go faster. We need to go a whole lot faster. 5. Um, continuous and differentiable function. Okay, so this is continuous. So the right hand side uh, must equal the left hand side, right? So at x equals -1, right? X equals -1, they both meet the left hand side and the right hand side must be the same in order for it to be continuous. Otherwise, they're not continuous. So I'm just going to set m -1 plus 2 equal to -1 squared plus k, right? So we have -m plus 2 equal to 1 plus k, -1. Okay, so then we have that set up. Okay, just half time. Okay, so we should be done with question 5 by now, but it's all right. So if it's differentiable, then also the derivative from the left-hand side and the derivative from the right-hand side must be the same. So we can also set the left and right-hand derivatives as well. So f prime is equal to, just take the derivative of the top and bottom. So m, that's the derivative of that for x is less than -1. And then the bottom is going to be 2x. X is greater than -1, or greater than -1. All right, so that's just going to be, m is going to be equal to, I mean, there's no x here, so there's just m. It's going to be constant m. And then here it's going to be 2 times -1. So m is just equal to -2. So then now we plug in -2 into here, right? So then -2 plus 2 is equal to 1 plus k. Now we're able to solve for k, right? So this is 4 minus 1, so k is equal to 3. So then m plus k is -2 plus 3, which is equal to 1. Okay, let's move on. Okay, actually this is not that bad. I think this one's pretty simple. 6d dx, x squared here, 7 up here, x squared sine t dt. Okay, so this is just second fundamental theorem of calculus. Whenever you see a derivative and integral next to each other, just be on the lookout for that. Here, what you need to do actually is the formula only works if you have the export at the top. So there's this right here. So a to b of f of x dx. It's like if you go backwards with the integrals, instead of going from a to b, let's say you go from b to a, then the integral becomes negative. So if you're going from one way, so if you take the integral one way, it's going to be positive. But if you go the other way, then it's going to be negative. So here, what is it now? We can flip this around, right? So we have x squared at the top, 7 at the bottom, and you have this over here. But then it's just going to be negative, and then so you get this right there. So then now you have this negative at the front. And then now what you do, second fundamental theorem of calculus, I don't have too much time, but you just plug this into here, right? So you have half sine x squared, assuming that you have the derivative out front. You put the x squared there, then you take the derivative of whatever is there on inside. So you have 2x. So then what you're left with is negative x sine x squared, which is which of the following could be the slope field? dy dx is equal to x plus y. Okay, good thing to note. Okay, so if x is equal to 0, I like to always start the origin, right? So if you had 0, 0, the slope would be 0, right? If you had x comma y, 0, 0, then dy dx is going to be 0 plus 0, which is 0. So we need to find a place where it's 0. So basically that rules out c. So we're left out with a, b, and d. Now, if we had x plus y, right? If x was positive and y was positive, then the derivative, right, the dy dx, the slope must also be positive. So we should see like a positive slope here. Is there anything with a negative slope? No, that's not fortunate. Oh, another thing too, let's say you had x and y. So let's say x is equal to negative y, then the slope will also be 0 too, because you put a negative y into there. Negative y plus y is equal to 0, right? Y minus 1 is 0. So whenever you have like 1, -1, or -1, comma 1, or these points would be in either the second or the fourth quadrant, they would have a slope of 0. So over here we see like, okay, let's say like 2 comma -2, right? For b, there's no slope of 0, so it can't be b. So we're left with a and d. Um, D, like c. I Okay, let's say if you had x is negative and y is negative, then the slope will also be -2. So if you look at the third quadrant over here, let's say like -2 and 2, right? So let me give my mouse back again. If you have -2 and -2, right? The slope would be like -4, but here we have a positive thing, so it can't be a. So we're left with this d. So like you have -2 plus 2, 0, slope is 0, perfect. And then what is it? You have something negative, add those together, you have a negative slope, and then 0, 0, slope is 0. So it has to be. Yeah, see, it's just reasoning your way through. Uh, oh, uh, that's interesting. All right, let's do this. This I haven't seen these in quite a while. Tangent inverse of x plus 2. Okay, I'm going to suppose you don't remember these formulas. All right, what is tangent? So y is equal to tangent inverse of x over 2. Okay, so like if you know that, okay, so like the tangent of 45 degrees is 1. So the tangent inverse of 1 is 45 degrees, right? That's what the relationship. The tan inverse tan or arctan finds you the angle. So in this case, y is an angle and x over 2 is like a side length ratio. So then we can actually flip this around by saying tan of y is equal to x over 2, right? And then now we can just do implicit differentiation. So then here we have secant squared y uh, times dy dx, because yeah, the derivative of tangent is secant squared. Then remember we're taking the derivative with respect to x, so y, you have dy dx. Then over here you just have 1/2. How much time do we have? Okay, we need to speed up. So then now, if you do dy dx, if you just isolate that, the derivative, right, which is h prime of x, I should just say, is just what is it, 1/2 over 1 over secant squared. But then 1 over secant, that's just cosine, right? Because 1 over cosine is secant. So 1 over secant is cosine. So then we have 1/2 cosine squared y. Um, but now what is um, cosine squared of y, right? So here we determine the tangent of y is equal to x over 2. And honestly, we can just draw a triangle. So if you have an angle of y and the tangent, if you remember from trig, tangent is SOHCAHTOA. So it's opposite over adjacent. So opposite is x and the adjacent is 2, right? So opposite over adjacent. And then what is it? Then now if you want to find cosine, it's just adjacent. So I'm just gonna have what is it? It's just gonna be adjacent over the hypotenuse. The hypotenuse by Pythagorean theorem is the square root of x squared plus 2. So this is adjacent over hypotenuse. But then this entire thing is squared, right? So this is cosine, so it's half times 4 x plus 2. I probably messed up. Oh yeah, here it should be 4. I just messed up. So it'd be 4 here, 4 here. So then it'll just be 2 over x squared plus 4. Okay, we need to speed up quickly. Oh no. Otherwise I'm going to run out of time. So this is B. Um, oh, okay. Fortunately, I've done this question before. So I'm just gonna skip on. It's basically saying G prime is greater than 0, G double prime is less than 0. G prime is greater than 0 means that G is increasing, and G double prime less than 0 means that it's concave down. So it's gonna have some sort of shape like this. And like say it's like G of 1 is 2, then like G of 4 is 7, and then G is 7, right? So then here, like if it was straight, it was like completely straight, then it would go to 12, but then it's coming down, right? So then has to be less than 12, so it'll be 10. And then okay, let's go to the last question. You can watch previous videos in me explaining that. Oh my god, okay. I hate these with the fashion. You know, like, well, let's try doing it. How much time do we have left? Okay, we have 2 minutes. Let's see if we can do this. Um, 1, 2, 4. Okay, these are just Riemann sums. Uh, so the absolute value just means you're going to get this positive area. There is a formula for this. Okay, to be completely honest, you don't need to really know this. This is just really scary. But this is just okay. So if you were to do a Riemann sum, right? Like say you had 3 rectangles, then n refers to the number of rectangles. So and then k just refers to like you're starting from one, so you have these subsections right there. So honestly, I don't really want to explain this. It's just there's a formula for Riemann sums. Honestly, it's not really worth your time studying this. It's really not. And if you get one question like this, okay, just like forget about it. I mean, yeah, I could explain this, try explaining this, but okay, so let's say we had 3 rectangles. Let's see if we answered all the other questions first, right? Yeah, we answered all the other questions. Actually, let's check to see if we answered everything. 10, 4, yeah, yeah, yeah. Uh, yeah, I got an answer for that. G of x. Yeah, outer minus axis squared minus inner minus axis squared. Yeah, this is area. Okay, let's see how I did. 8 out of 10. Okay, fair enough. Oh, it's D. 1 and 3. Hmm. Yeah, see, areas are my weakness, but it's all right. What is this? Area close to the graphs. What does this show? Negative pi over 2, 3 pi over 2. Oh, oh yeah. Oh yeah, duh. Okay, so I don't know what this is. Okay, I think no, I just screwed up. I screwed up a big time here. Okay, I was just being really dumb. Let's see here. What this is trying to do is just trying to find this area. If you're trying to find area, we're just trying to find the positive difference here, right? And if you look from negative pi over 2 to pi over 2, right? Let's just say negative pi over 2 to pi over 2. We're doing f of x minus that, right? Uh, and then we're adding on pi over 2 to 3 pi over 2. Then now we're doing top minus bottom again. So then you have this minus f of x, right? Um, but like let's say you flip this around, right? So then now you just have minus. You can negate each other. So like you flip this around, so then you have a negative answer, and then you can subtract, right? So you have f of x minus. Yeah. So then, but the thing is, you can also what you can do is you can just take the absolute value of this, right? And you just take the absolute value because and if you take the absolute value, you're gonna have the positive area. So because what you did if you subtract this and you get a negative answer, right? Then and if you do multiply that by dx, you're just going to get like a negative area. But if you just make that positive, then the entire thing will become positive. So then you can just add this, right? So then you just have this positive area that you're adding back again. And then now these two are just basically the same thing, right? Then now you can just, this is already like a positive sort of area. So then you can just add this on together and then you just combine. So it's negative pi over 2 to pi over 2. And here's pi over 2 to 3 pi over 2. So you can just smush those together as negative pi over 2 to 3 pi over 2. Um, yeah, and then you have this right here. All right. And then, so okay, the reason why B is incorrect is because you're taking this negative, if you have f of x minus f1 of x after pi over 2, so right over here, then you start to get negative area and then they cancel each other out. So then this area will give you like approximately 0 because these two are approximately the same. But like these two, the area of this is definitely not 0, right? So um, basically, yeah, here's like, if you have to do f of x minus 1, you don't take the positive then. You're having a bunch of positive area and adding a bunch of negative area together and they cancel each other out. So it can't be B. So yeah, we're left with D. So that was just a stupid mistake on my part. What else did I get wrong? Oh, okay. I got this one wrong. Um, okay, makes sense. I mean, I'm not too worried about this. Um, if this comes on the exam, I'll just be like, okay. They're not gonna have like a few response on this, I swear. If they do, then kind of bad. But let's see what they're trying to say here. The natural log of 1 over. Oh, I see. So these are just Riemann sums, right? So I'll just go over what a Riemann sum is, right? So then we have this function right over here, and it'd be like, okay, try to find the area between 1 and 4, right? So here's what we're gonna do, right? So let's just say we have 3 rectangles, and let's just approximate each of these. So we have x, and then f of x. So then you have 1, 2, 3, and 4, right? So suppose, okay, natural log, this is definitely 0, right? Natural log of 2, sure, we can just say natural log of a half, right? This is natural log of a third, and then this is natural log of a fourth, right? So suppose that we had 3 rectangles, right? And we're going from 1 to 3, 1 to 4, right? So then now each of these, the length of this is just going to be 1, right? But let's say now we had 6 rectangles, right? So now if we had 6 rectangles, we know we have to split these intervals by half, right? So we go 1.52, we have 2.53, and then we have 3.54, right? Then what we do is we took our interval, which is 4 minus 1, right? And then we just divided it by the number of rectangles that we had, which is 6, right? But what if we had an n number of rectangles? Then similarly what we do right here is you just take our interval, 4 minus 1, and just divide by n. So these are the number of rectangles that we're going to have, right? Now for each rectangle, what we're going to do, um, here, let's say if we do a right Riemann sum, like if you're just adding up a bunch of right triangles, not right triangles, right rectangles here, what you're going to do is you're going to take the rightmost, over here, you're going to get natural log of 1/2, and then multiply that to your width, right? So here your width is 1, and then here you're just going to add uh, natural log of 1/3 times 1, and then you're going to add, so this is natural log, yeah, this is going to be natural log of 1/2, natural log of 1/3, natural log of 1/4, etc. So then now you're just adding those together, right? So then now, in terms of like in this integral right over here, um, okay, let's try to find an easier way. Okay, so now let's say we're going to have like 6 rectangles, right? It's going to be approximately this, but then now the width of each rectangle, if you have 6 rectangles above here, each of the width is going to be a half, right? So, and then now it's just going to be 1/25 times 1/2 plus natural log of 3 times 1/2. And then you're just going to go all the way until you get to natural log of 1/4, right? Because our interval is still 1/4, right? Okay, now, okay, I don't know why I'm starting with 2. Wait, no, actually, it kind of makes sense. Okay, but basically the same idea is like, okay, now what if you had n number of rectangles, right? So then we start off with 1 over here, and then instead of 1/2, I mean, here it was like 3/6, right? So it's the interval over the number of rectangles. But if you had n number of rectangles, it would be 3 plus n. And then you're just going to add on natural log of 1 plus 2. But like, here we know we need to add by a half, right? So here we just add by n. And then you just do 3 plus n. And then here it's going to add on 1 to n, right? So this over here, this is going to be counting over here, and multiplied by 3n. Okay, so then now we have this knowledge over here, so it has to be either A or B, right? And by looking at this logic over here, how we're adding, right, numbers over here, we're not adding it over to the natural log function. Like the natural log, the 1 over x thing, right? If you look at the function, like if you look at the similarities between what's given in the question, what's in the answer over here, we have this 1, let me get my mouse again, but we have this 1, and then we have 1 plus our x right over here. Here we don't have the same form of f of x, but this is the form of f of x, and we want to model f of x as close as possible when doing these unit sums, so therefore the answer is B. I was just, I just chose the answer too fast, not really considering this is the actual natural log that we're doing, not 1 plus a natural log. But yeah, honestly, do not worry about these questions at all. They could have happened at least once on the AP exam. Maybe it doesn't even come up at all. Don't worry about it. But yeah, I'm gonna end it here. Thank you for watching. Hopefully you'll do well on the AP Calc EP exam. Don't worry about it. This curve is really high for the exam, so you can miss a bunch of questions and still do really well. Anyways, good luck on the exam, and hopefully my videos help. All right, thank you.